Our next speaker is Emaad Paracha, who is a PhD student at the Department of Physics with a talk titled Detecting Dark Matter in Galaxy Clusters from the Stratosphere.
What is the universe made of? You might say stars and galaxies, things we can see, but they only account for 15% of the mass of the universe. The other 85% is actually in something we can't see. It's invisible, and it's called dark matter. But how do we know it exists? Because of gravity. So gravity is essentially the bending of the universe. Now imagine you have a trampoline and you put a bowling ball in the center of it, it'll bend the trampoline. And then if I throw a marble, the marble doesn't go straight, it curves around the bowling ball. That's how Earth revolves around the sun because of sun's gravity. So big things bend the universe. And if you look at even bigger things, so a cluster of thousands of galaxies, they're so big that they even bend the path of light itself. So if I'm here and there's a cluster of galaxies in front of me and then there's another galaxy behind it, like in the slide, the light from that galaxy bends as it comes to me, and that galaxy appears distorted. So a circular galaxy, for example, would look oval-shaped, and that's called gravitational lensing. So when you do the math, when you try to see how much mass there is in the stars and galaxies in a cluster, you'll see that they only account for 15% of the mass that's causing the bending. So the other 85% that's causing the bending is this dark matter. And we only call it dark because we have no idea what it is, but we can see its effects through lensing. So the first part of my research is I'm studying images of lensed galaxies to map out the distribution of dark matter in galaxy clusters. And with that, what I'm trying to understand is what is dark matter made of, how it interacts with regular matter, and how come it constitutes 85% of the universe. But I have a little challenge, and the challenge is that it's really hard to see it from the ground. I'll see a blurry blob because of the atmosphere. So I need to go out to space, and space is expensive. So NASA has a really good telescope up there called Hubble, but Hubble costs $15 billion, and it's coming to end of life. So the second part of my research is I'm collaborating with NASA to build and launch balloon-borne telescopes like SuperBit, which we launched last year from New Zealand, and we built it here in Toronto. Now that balloon looks small, but when it is fully inflated, it's larger than the size of a football stadium. And it goes up to the stratosphere, to 110,000 feet, which is above 99% of the atmosphere. So we're in a space-like environment, and we get to see the exact same thing that Hubble does. Except Hubble was $15 billion, and we are 3,000 times cheaper at $5 million. So with this, I'm helping create tools to make it cheaper and more accessible to study dark matter, to study weak lensing, and to answer the question of what is our universe made of? Thank you.